So hello everyone. Today we are going to solve our next question on LeetCode, and that is product of array except self. So the question is saying that we have given an integer array nums and we have to return an array answer such that answer of I is equal to the product of all the element of nums except nums of I. So what it is saying, let's say we have this array. So this is our nums array and we have to return this answer array. What we have to put in this array, basically for this element 1, we have to put here the product of all the elements in this array except this one. So it will be equal to 4 into 3 into 2, that is 24. Now for this element 2, here we will put the product of all the elements in the array except 2. So it will be equal to into 3, 12 into 1, 12. Similarly for this 3, we will put it 4 into 2 into 1, it is 8. And here we will put 3 into 2, that is 6. So this will be our final answer. Now let's try to solve this. So here we will take this example to solve this. Now, the first approach that comes into our mind is the easiest approach, and that is first we will traverse through this array nums. And what we will do, initially we will take this product whose value is equal to 1. And what we will do, we will start traverse from this first element and we will go till last. And what we will do, we will simply take each and every element and product it with this product element. So finally, when we will product all the element into this variable, so the final answer will be equal to product equal to 5 into 4, 20 into 3, 60 into 2, 120. Now after that, what we will do, we will take an array answer. We will take an array answer of similar size. After that, what we will do, we will again traverse into the same array. And what we will do, in this answer array, what we will store, we will store this product divided by this nums of I. So here we will store 120 by 2, that is, so here we will store nums of I. So 120 by 2, that is 60. 120 by 3, that is 40. 120 by 4, that is 30. And 120 by 5, that is 24. But this is not the expected answer. Why? Because the question is saying that we have to implement an algorithm where we will not use this division operation. So what we are doing here, we are doing this division operation. So we cannot use this division operation. So this is not the expected solution. So now let's try to solve it in different way. So now the second approach to solve the question is, this is the second approach. And the second approach to solve the question is what we will do, what we have to do here. At this place in answer, at this place in this answer array, what we have to store? We have to store the product of all the element in this nums array except this particular index. So here we will store 5 into 4 into 3 and so on. Now what we can do is we will traverse through this array. Initially we will take 2 pointers. Initially we will take 2 pointers here. The pointers are I and j. Pointers are I and j. And what we will do, when this condition meets, when this I is equal to j at any point of time, here we will continue. We will simply skip this case. So here, as we can see, for this 2, this I is equal to j. So what we will do here, we will simply increase this I pointer. So this I pointer will increase and we will take a product variable whose value initially is equal to 1. And we will simply take the element and product into it. So that after that it will be 3. Then we will come here at this place. Here I is not equal to j. So we will simply take this and multiply this into this product variable. So it is equal to 12. Again, we will come here at this place, and 5 into 12 is 60. So here at this place, we can simply put 60. After that, what we will do, now we have done this for this element. After that, we will increase this pointer j, and we will perform the same thing for every element. After that, we will get one answer. But there's a problem in this approach. For every element, we are taking the product of every other element, and we are going to put it here in this array. But in this in worst case, this solution will not get accepted. It will throw TLE. Why? Because as if we will see here on the constraint, then it is saying that the length of this array will vary from 2 to 10 to the power 5. So it will vary from 2 to 10 to the power 5, and in worst case, the size of this array can be 10 to the power 5. Now here what we are doing, for every element, we are checking with every other element, and we are taking all the elements and multiply it into this product variable. And we are performing this for each and every element in this array. So if we will see the time complexity of it, then it is basically equal to O of n square. That is quadratic time complexity. And in worst case, if the size of this array is equal to 10 to the power 5, then the solution of O of n square will execute and take 10 to the power 10 iterations. But this LeetCode compiler can only run 10 to the power 9 or less than 10 to the power 9 iterations. It cannot go beyond this. If it will go beyond this, then it will exceed the limit, the time limit in which this solution has been accepted. So it will simply exceed the time limit. So that's why in this case, in worst case, for a small number of input, it will definitely run. But for larger input, where the size is equal to 10 to the power 5, it will simply throw time limit exceeded. So the solution is not going to be accepted. Now let's try to see a different approach for this solution. Now, as we know that what we are doing here, let's say for this element, what we are doing, we are multiplying all the elements except this 3. For this element, we are multiplying all the element except this 3, and the final result we will place on first index in this answer array. In this answer array. So what we will do, except this 3, we will take all the element, multiply them all, and after that final result we will place it on the same array, that is on first array, first index. Okay, so as we can see here that the result which is placed on this position in this answer array is equal to the product of all the element before this element, the product of all the element before this element, that is 2, into the product of all the element after this element, that is 4, into 5. So this is 40, which will be placed here at this place. So this is what we are doing here. So what we can do here is, what we will do here, what we will do here, we will take a prefix array. We will take a prefix array. We will take a prefix array of similar size as the size of this nums array, and we will take a suffix array. We will take a suffix array of the similar size. So this is our prefix array, and this is our suffix array, and this is our answer array. Now what we will do, for this element in this prefix array, first we will populate this prefix array, after that we will populate this suffix array. So for this place to be populated, what will be kept here? Here we will kept all the element that are prefix to this 2, that are prefix to this 2. So here what we will keep, as before 2 there is no element, so we will simply keep 1 here at this place. After that, we will move forward at this place. In this place, what we are going to keep? In this place, we are going to keep all the elements that are prefixed to this three element, product of all the element that are prefixed to this three element. So basically prefix to this three element is 2. So we will put this 2 here at this place. After that, we will increase the pointer. Now again, what we are going to keep at this place, basically we are going to keep all the element, the product of all the element which are prefixed to this 4. So which is equal to 3 into this 2. So which is equal to 6. Again, we will move this pointer. And here we will put the product of all the element which are prefixed to this 5. So it is 4 into 3 into 2. That is 24. So in that way, we can get all the prefix element. Now what we will do? Now we will take a loop and start filling this suffix array. So what we will do here, in this suffix array, we will start looping from back. So we will start looping from this element. And what we will put here at this place. So as we know, after this 5, there is no element. So there is no suffix after this 5. So simply we will put this 1 here at this place. Then we will decrease the pointer. Now what we will store here at this place? So we will store all the elements that are suffixed to this 4. So the element that are suffixed to this 4 is 5. So we will take 5 and put it here at this place. After that, we will decrease the pointer. Now here we will store all the elements, product of all the elements which are suffixed to this 3. So it is 5 into 4, that is 5 into 4, that is 20. After that, we will decrease the pointer and decrease the pointer. After that, here we will store the product of all the element. Here we will store the product of all the element which are suffixed to this 2. So it is 5 into 4 into 3, that is 60. So we will put 60 here at this place. And after that, finally what we will do, we will loop through this array, and what we are going to store in this answer array, we will simply store the product of this prefix and this suffix. So here we will store 60 into 1, that is 60. After that, we will come here at this place, and here we will store 20 into 2, that is 40. Here we will store 6 into 5, that is 30. And here we will store 1 into 24, that is 24. And this is our final answer. Now, what is the intuition behind solving this question like this? First, we are taking a loop on this prefix array. We are going to simply extract these prefixes from this nums array. After that, what we are doing, we are populating this suffix array, and after that, we are multiplying this. So the intuition behind this approach is, let's say for this element 4, the answer will be the product of all the element that are suffixed to it, that is 5, into the product of all the element that are prefixed to it, that is 2 into 3, that is 6. So it is equal to 30, and 30 is the answer here at this place. So we are doing the same. First, we are getting prefix here, and then we are getting suffix in this suffix array, and simply after that, we will simply multiply this to get the answer, and finally we will get our answer. So let's try to write the pseudocode for this approach. Let's try to write pseudocode for this approach. Or directly I'm going to code this. So let's code this. So what we will do here, first we will take an array result to store the result into it, and it is of similar size as the size of this nums array. After that, we will take an array to store all the prefix here. So we will take an array to store all the prefix, and it will also be of similar size. After that, we will take a suffix array of similar size. And now what we will do, first we will try to populate the prefix array. So as we know that for the first element, for the element at 0th index, there is no element prefix to it. So we will simply put 1 in this place. So we will simply put 1 in this place. After that, what we will do? We will simply start looping from first index, and we will go till the last index. We will go till the last index. And what we will do? We will simply store this prefix of I is equal to prefix of I minus 1 into nums of I minus 1. Now, why we are taking this nums of I minus 1? Because for a particular index, we are taking all the elements that are prior to it. So we will take all the elements that are prior to it, and we will simply put up these both. So this is how we can get this prefix array. Now we will try to get the suffix array. So what we will do, as we know that we will start from last, because here we have to find the suffix for every element. So what we will do, as we know that for the last element, there is no suffix. So in the last place, what we will do, in the last place, what we will do, we will simply put 1 here at this place. After that, we will start looping from the second last element. And we will go till 0 index, I minus minus. And what we will store in this? So we will store that suffix of I equal to suffix of I into uh, suffix of I plus 1 into nums of I plus 1. Because here we will take all the elements that are after that particular element. So here we will take all the elements, the product of all the elements that are after that particular element. And finally, what we will do, we will loop through this result array. We will loop through this result array. And what we will store into this result? So we are going to store this prefix element, the product of this prefix element, and the product of this suffix element. And after that, finally, we will return this result. So let's try to run this. So it is accepted, and let's try to submit this. And it is submitted. But now there's a problem in this approach. If you will see that here the time complexity it is taking it is O of n. So the question is also saying that we have to design an algorithm that will run in O of n time complexity. But the space complexity it is taking is also O of n. Because if we will talk about this result array, then basically we have to return this answer array. So it will not take any extra space because it is the part of the question, because we have to return it. But here we are also taking two arrays, that is prefix and suffix. So here we are taking these two arrays, that is prefix and suffix. So its space complexity is O of n plus O of n. That is approximately equal to O of n, that is linear space complexity. So now let's try to decrease this. So we will design an algorithm that will work in O of 1 space complexity. And this result array will not considered as an extra space, as we have to return this result array from the answer. So now let's try to design an algorithm to solve this in O of 1 space complexity. Now what we will do is, let me write it again. And this will be our answer array. Now what we will do here is simply first we will try to get all the prefix and store into this answer array. So what we will do, initially we will take a variable that is, let's say, current, which is equal to 1. Now what we will do is, we will simply store all the element into this answer array, which is a prefix element. So if we will see in this case, then for this 2, there is no prefix element. So what we will do, we will simply store this current into this answer. So what we will do here is, we will simply do answer of I equal to current. Answer of I equal to current. So here we will store this one here at this place. And after that, what we have to do is, now we are on first on 0th index. So here we are doing this answer of I equal to current. But now, as if we will move forward on this index, what we have to do now, for this 3, this element 3, this 2 is a prefix element. So we have to include this into this current variable. So what we will do, we will do one more thing, that current into equal nums of I. Current into equal nums of I. So first we will store this current variable into this answer, and after that what we will do, we will simply take this element and product it with this current variable. So now this is equal to 1 into 2, that is 2. Now we are at this place. What we will do, we will simply store this current variable on this place. So it will be 2. After that, we will take this variable 3 and product it into this current variable. So now it is equal to 6. After that, what we will do, we will move forward, and then we will store this answer of I equal to current, that is 6. After that, we will do current into equal nums of I. So basically we will take this element and product it into this current variable. So it is equal to 24. After that, we will simply increase this pointer. We will simply increase the pointer, and again we will do the same. We will simply store this current variable into this answer array. So it is 24. And after that, we will simply take this last element from this nums array and product it with current variable. So it is equal to 120. Now we will come out of the loop. After performing this operation, if we will see, then we can see that here we are storing all the prefix. Here we are storing all the prefix. Let's see. For this 2, there is no prefix. So simply we are storing 1 here. For this 3, the prefix is this 2. So we are simply storing 2 here. For this 4, the prefix is 3 into 2. That is 6. Similarly, for this 5, the prefix is 4 into 3 into 2. That is 24. So for the first time, we are storing all the prefix here in this array. After that, what we will do, we will again loop through this array. And now what we will do, we will start looping it from the last index. We will start looping it from the last index. And what we will do, again, we will take this current variable and put it as 1. Now we are going to store all the suffix into it. We are going to multiply all the element with its suffix. So what we will do here, we will simply put it as answer of I into equal current. Because as we know, there is no element, there is no element that is prior to this element. There is no element that is prior to this element. This is the last element. So there is no suffix to it. So we will simply take this one and multiply it with this answer. So again, we will do this. Initially, we are at the last index of both the arrays. What we will do, we will simply do answer of I into equal current, because for this element, there is no suffix. So we will simply take this current, multiply into this, and simply put it here at this place. So this 24 will be 24 itself. Now after that, what we will do, we will do current into equal nums of I. We are simply going to multiply this nums this element into this current variable. Why we are doing this? Because as we will move backward into this array, then when we will come here this place, then for this element, this 5 is also included as a suffix element. This 5 is also included as a suffix element for this 4 element. Okay, so what we will do, we will do current into equal nums of I. So now this current is equal to, basically it is not equal to 1 now, it is equal to 1 into 5, that is 5. Again, we will decrease the pointer. So we will decrease the pointer, we will come here at this place. After that, we will perform the same operation, answer of I into equal current. So we will simply multiply this current variable into this 6. So 6 into 5 is 30. So this will be our next element to be filled at this place. After that, what we will do, we will simply do current into equal nums of I. So what we will do, we will take this 4 and product it with this current variable. So now it is equal to 20. Then we will decrease both the pointers. Again, we will do this answer of I into equal current. So what we will do here, here it is 2, and now as current is 20, so we will simply put 20 into 2 here. It is 40. It is 40, and then we will do this current into equal nums of I. So we will take this 3 and multiply into it. So now this 20 is replaced with 60. After that, we will decrease the pointer. We will decrease the pointer. Again, we will perform the same operation. This answer of I into equal current. So we will take this variable and multiply it with current, and the answer will be 60 into 1, that is 60. And then we will perform this current into equal nums of I. So we will take this current, this nums of I, and product it with this current variable. So now it is 120. After that, we will decrease the pointer, and as it came out of the loop, so it will terminate out of the loop. And as we can see, this is our final answer. So this is our final answer. So what is the intuition behind this? So what we are doing first, we are taking this current variable, and initially this current variable is equal to 1. And what we are doing, first we are trying to store all the prefix into this answer array. So first we will store all the prefix into this answer array. After that, what we will do, we will start from this last element and try to multiply these prefixes with all the suffix. And as we know that for any element in this nums array, the answer in this the element in this answer array is equal to all the elements that are prefixed to it, the product of all the elements that are prefixed to it, and the product of all the elements that are suffixed to it. For example, for this 4, uh, the element in this answer is equal to the product of all the element that is before this 4, that is all the prefix element, that is 3 into 2, and the product of all the elements that are suffixed to it, that is 5, which is equal to 5 into 3, 15 into 2, 30. So as we can see, there is 30 in this place. So first we are trying to store all the prefixes into this answer array. After that, what we will do, after that we will multiply all these prefixes with their corresponding suffix, and we will finally get this answer. So here, as we can see, that this is the answer array. So there is, so it will not take any extra space. And as now we are not taking any prefix or suffix array to get these prefixes and suffixes, so the time complexity in this case is O of n, and the space complexity it is taking is O of 1, that is constant time, constant space complexity. So now here we have decreased the space from O of n to O of 1. Now let's try to implement this. Let's try to implement this. So here let's implement this. So what we will do here, initially we will take a current variable that is equal to 1. After that, what we will do, we will take a result array which we have to return, and it is equal to the length of this nums array. After that, what we will do, we will start from the first index, from the 0th index, and we will go till end. And what we will do, simply we will take this variable here at this place. Okay, then what we will do, we will simply store this answer of I is equal to current, and after that we will simply multiply it with this element inside nums. After that, what it is doing, it is storing all the prefix into this answer array. After that, what we will do, now we have to extract all the suffix. So we will start from the last index. So we will start from the last index, and here we have to take this uh, current variable as 1 again, this current variable as 1 again. And what we will do here, uh, we will do this answer of I into equal current. After that, this current to equal nums of I. And finally, we will come out of this and simply return this answer. Now let's try to run this. Okay, it is not answer. So let me make it answer. Okay. So it is accepted. Let's try to submit this. And it is accepted. So that's all for today. Thank you.